Hello and welcome to CoreTalks, CoreAVI's technical podcast series. To follow along from our last technical podcast, which talked about migration from OpenGL ES to OpenGL SC, today we're taking a look at how integrators can migrate from Vulkan to Vulkan SC. I have with me here today Neil Stroud, the General Manager of Automotive and Embedded here at CoreAVI, and Peter Papadatos, the Director of Product Development. Welcome both.
Hi, Mary Beth. Hi, Peter.
Hello, Mary Beth, Neil. Good to be with you again for this interesting talk that we'll be having.
Okay, so to begin, OpenGL has been a really popular API for years now. Developers are very familiar with it. Why would integrators move from OpenGL to Vulkan?
It's a great question. I think if we look at the advantages of Vulkan, first of all, as an API, it was developed to maximize the performance that you can get out of an underlying GPU. Importantly, both from a graphics but also a compute perspective as well, as we get into more compute-driven applications, GPU applications, and we can address that later on in this discussion. So I think there's an immediate performance benefit from migrating from OpenGL to Vulkan. And of course, we're here to talk about Vulcan SC as well, and the differences between Vulkan and Vulcan SC and the benefits that Vulcan SC brings for safety critical applications. So I think one key advantage for developers is around performance. The other one is around a drastically improved ROI for their application development as well, because the Vulkan layer can bring hardware abstraction as well, so you can scale across multiple SoCs. And again, we'll touch in more detail on that through this conversation. Peter, how about you? What are your thoughts?
Yeah, that's a very important aspect to kind of understand around the Vulkan offering. Definitely performance is a key element in terms of migration. In addition, I would say that Vulkan is a lean interface focusing primarily on hardware abstraction. And the key benefit to that is the power that it gives to the application developer. If you think about it, we've evolved from fixed function pipelines such as OpenGL SC1, then to a more programmable pipeline in OpenGL SC2. Now we're maturing as an industry to Vulkan SC, giving the flexibility to the application so that they can tailor and differentiate themselves from their competitors for that matter. So when you think about it, giving that freedom to the application will allow you to control your look and feel of the graphics that you are producing, the scenes that you are creating, and not carrying that burden of an interface that needs to be all encompassing. Vulkan SC provides the necessary building blocks that give that control over to the application. And for me, that's a huge benefit. In addition to the fact that Vulkan SC not only provides a graphics offering, but also includes a compute offering, which is definitely something that as an industry we're leveraging more.
So the Vulkan API has been around for a while, right, Peter? And it's used extensively in graphics applications in the consumer space and gaming, and also parallel compute and those kind of things. Vulcan SC, I think, was first mooted probably 3+ years ago. And as the listeners may or may not know, CoreAVI worked with the Kronos organization and other players in the industry to set up the Vulcan SC working group and get that ratified, which actually happened about a year ago. So we do have an industry standard. What are the key differences between Vulkan and Vulkan SC? I mean, clearly Vulkan SC is targeting safety critical applications across multiple segments and multiple use cases, but can you kind of define the differences between the general Vulkan standard, commercial Vulkan, and Vulkan SC?
Sure, definitely. Before I address that directly, I will take a step back and just kind of walk us through the evolution of OpenGL ES to OpenGL SC, because there are a fair amount of parallels between migrating from OpenGL ES 2.0 to OpenGL SC 2.0. And last time we met, we talked about determinism and memory management, resource management in terms of safety critical compliance. A lot of memory is allocated up front and dispersed as needed, with eliminating any form of dynamic usage of both memory pools and resources for that matter. Vulkan carries forward or picks up with that construct similar to that that I just described. So the key differences between Vulkan and Vulkan SC orbit around the shaders. Vulkan, online shader generation, Vulkan SC, offline similar to how we described that with ES to SC in the last podcast. But Vulcan SC builds on that safety critical pedigree that was developed for OpenGL SC2. Other things that have been added to the Vulcan SC standard are fault callbacks. In a safety critical system, it's imperative that an application is notified of key events, such as when the device is lost or when your command buffer memory pool is exhausted. So with callbacks, the application is notified immediately as opposed to being told that you are full and you have to recourse at perhaps a non-opportunistic time within your drawing scene. So I guess just to kind of recap, that the key benefits to Vulcan SC over Vulcan are in the areas of fault callbacks, and again, building on the determinism with respect to eliminating functions that require dynamic state management and dynamic resource management. Another key item that sometimes or maybe overlooked with most is Vulcan SC is also thinking ahead, looking at compliance to MISRA and AutoZAR, where with Vulcan, those notions are for the most part ignored.
Okay, that's really helpful actually. So as a developer, could I then start with development on a commercial Vulkan driver, which is available from most of the SoC GPU vendors? Can I start with that to enable me to shift my development further left and get some time to market benefit, and then migrate to Vulkan SC as it becomes available or a certified version becomes available downstream a little bit? Is that a viable development model?
I would say that definitely is a channel that can be leveraged, although I would caution the developers to be aware of the differences so that they construct their application to be easily portable from one to the other. I guess the way that I would say it is Vulkan SC is not a superset or a subset of Vulkan. In essence, Vulkan SC has a large overlap with Vulkan. So, as with any development that we undertake, understanding the end goal is key. So as long as the developers understand the nuances around the shaders and how they would need to be adapted from a deployment perspective, going from Vulkan to Vulkan SC, I see no hindrance in starting your development with Vulkan and then migrating over to Vulkan SC based on the availability of the platform for Vulkan SC.
And that's an important point. Okay, let's shift gears a little bit. I want to move across to the hardware abstraction piece, because I think that's, for me, seems a really important advantage as well, especially in these silicon constrained times. And think about the automotive industry especially. You look at the stacks that go into a vehicle today, they're very, very tailored to a specific underlying SoC. And of course, as we've seen over the last year, 18 months, 2 years, we've been living in very silicon constrained times. And in some cases, vehicle manufacturers have even gone online stop because they can't get hold of the semiconductors. So I see Vulkan SC as a means to providing the benefit to these developers, that they can build their application stack and to a certain extent have what I would call port of choice, so they can have and support multiple underlying SoC architectures and GPU architectures with perhaps minimal changes to the application stack. Is that a correct thinking, Peter? Is that something that can be achieved?
Yeah, portability is definitely I would say, top of mind, not only from application development perspective, but also from implementers perspective. If you think about, 10 years ago, there was a lot of custom drivers. Everybody would kind of create their own variant of various standards, at least from a safety critical perspective. And I think without a doubt, we're seeing the value, or at least people are recognizing the value of standard API and leveraging that across the graphics and compute stack. So, for example, CoreAVI leverages the fact that Vulkan SC is a defined standard, and we use that as a hardware abstraction layer. So there's benefits in terms of that standard from a CoreAVI perspective. Now, advancing upward on the stack from an application perspective, if silicon is not available, you can develop your application on a platform and implementation that is available. And because of the defined standard and mechanisms such as conform that we obey to heavily in terms of making sure that the offering is consistent across implementations, the risk is mitigated to have the application develop on maybe not the platform of choice for their end product, but something intermediate that is available, and they can make headway with their designs and implementation that way.
So I could even start developing on a desktop PC before the target hardware is available and ready, and then migrate once it becomes available.
I would say that that's a something that we promote with our customers, because we do have Windows and Linux drivers that can definitely work off of your PCs to develop the end product. So without a doubt, leveraging the CoreAVI offering from that perspective is helpful. And touching back to what we discussed a little while ago, where you can also use Vulkan as a stepping stone towards Vulcan SC as part of your development or execution plan.
So I got another question for you now. We're drawing tight on time already, but another important point I wanted to talk about is back to the point Mary Beth made at the beginning. So if my platform is on either GLES or GLSC today, how easy is it for me to migrate over to a Vulcan SC based platform? I mean, first of all, is it worthwhile doing that? It sounds like from the comments we've already made, it probably is. But is that a heavy lift? Is it worth paying the price in development hours and cost to make that migration, because you're going to end up in a better place? So what's involved in that journey?
Funny you ask. As you were stating the question, I grinned a little bit, just because I'm not gonna lie. Vulkan is going to be a heavy lift. The pivot from what I'll call legacy OpenGL ES and OpenGL SC, the approach is fairly different. So migrating from these legacy interfaces to Vulkan or Vulcan SC will be a heavy lift. Vulcan SC, I would label them as driver-like APIs. They are the leanness and the fact that they are labeled as hardware abstraction interfaces, the fact that they are labeled as hardware abstraction, the fact that Vulkan and Vulkan SC are lean, low-level interfaces, implies that they are very close to the hardware, and I would label them as more driver-like than application-like interfaces, so that there is a fair amount of learning curve. But that goes with everything. I think when we migrated from a fixed function pipeline to a programmable pipeline, that learning curve needed to be absorbed by the application developers and the industry as a whole. But you gotta look at the benefits that we conveyed during this discussion, and there's many more that we haven't really touched on. So I think just like with everything, there's a learning curve, but you gotta weigh the benefits. There are techniques that you can use that we at CoreAVI leverage for sure in the form of Vulkan engines. Every application doesn't have to have a direct link to Vulkan. You can create these little engines, and we can maybe touch on that in subsequent discussions, where you abstract common entities that your application farm needs. So as a application developer, there's certain things that are reused across multiple applications. So instead of reinstantiating that aspect of Vulkan per application, you could create a little engine that in essence encapsulates the Vulkan elements to maybe produce some terrain layer, or produce font, or produce dials. And this way you don't carry that heavy lift across each and every application. If I may, and again, maybe we'll have different discussions on this specifically, but third-party format generator applications, I think as these companies come on board and embrace Vulkan, I think that the standard will further push towards adoption.
So migrating from GLES or GLSC to Vulkan it sounds like it's doable, but there's some work involved. And of course, listeners can come work with CoreAVI. We've got a lot of expertise in that area from both perspectives, so we can help on that journey if that's the journey the customer wants to go on. Of course, we shouldn't forget that we've got an interim solution for those customers who are not quite ready to go all in on native Vulcan SC. They can, of course, make use of our OpenGL SC1 and SC2 libraries that sit on top of our Vulcan SC implementation. So there's an interim step they can take that gets them on top of a Vulcan SC solution as an interim step, and then they can migrate in the next generation as well. So that not everybody wants to go all in all at once, and we can help them on that journey. And I think also to go back to what you said as well, I think that the intention here is to dig into a lot more detail around Vulcan SC in subsequent discussions, which I'm looking forward to doing with you. But I think this has been a good discussion. It's helped to kind of do a high level setting of the value of Vulcan SC and why developers should be seriously considering it for their safety critical applications.
Yes, it's been a great discussion. So we'll end it there. Thanks so much, everybody, for joining us on today's podcast. A special thanks to our guests today, and we look forward to bringing you more technical insights in the next podcast episode in our series. Thanks for listening today.